Hey guys, welcome to the lesson on exponential decay functions. If you have not seen the previous video on exponential growth functions, I suggest you guys go back, watch that video, and then come back to this one. We're going to start the lesson with a quick do now or a warm-up. This do now simply asks us to graph an exponential growth function, also known as a power function. So we covered 4 steps to graphing these things. Step number 1 was to find our a and b values, or actually was to find all the values of variables given. So in this case, we just have an a and a b. A is equal to 2 and b is equal to 3. We want 2 very important points in step 2. We want our y-intercept. I'm sorry, that shouldn't be a 1. Our y-intercept, which is 0, and whatever our a value is. In this case, our a value is 2. And when x is equal to 1, we multiply both a times b to get 6. So these are our 2 points that we're going to graph. Here's 0, 2, our y-intercept. And then we have 1, 6. 1, 6. Where did this point go? 2, 0, 2. Here you go. Okay. So those are our 2 points. I'm going to go ahead and then connect the dots and create my line. Now we also know that we don't have a k value. Our k value is 0, which means our x-axis becomes our horizontal asymptote. So I'm going to go ahead and connect the dots and create my line, and I'm going to get very, very close to that and never really touch it. Remember, our asymptote does not get touched. So that's my line, and this is my arrow. So that's kind of the warm-up that we're going to be working on, or kind of the stuff that we're going to be seeing today. Today's objective is, given an understanding of graphing exponential growth functions, students will be able to graph and use exponential functions to model exponential decay. We have a lot of vocabulary used in this objective, and again, a lot of this vocabulary comes from the previous lesson. So we're building on each lesson. The title of today's lesson is graphing exponential decay functions. So what is it exactly that we're going to be doing? Well, students will be graphing exponential decay functions using the 4 steps learned to graph exponential growth functions. So 2 new vocabulary words that we got to go through today. It's exponential decay function. Now, if you remember, our definition for an exponential function or a power function is just y is equal to a times b to the x power. It's called a power function because our variable is actually a power. Now, in order for it to be a decay function, it has to meet these 2 conditions. A has to be greater than 0, there's our a, and b has to be between 0 and 1. Now, what does it mean to be between 0 and 1? It means that it's going to be a fraction. Moreover, it's going to be a fraction less than 1. So there's an infinite amount of fractions between less than 1 and 0 that we can choose from. Our decay factor is going to be our b variable. So just like before, our b variable was our growth factor. Now it's also going to be our decay factor. And it makes sense. If you think about it, our growth factor before had b as a value greater than 1. Well, if it's in between 0 and 1, you're always multiplying by a fraction. So technically, you're dividing. Now let's analyze this parent function. Here is the parent function for our decay model. Similar to our growth model, it's going to be this little curve, or what I like to think of the other half or the other side of my half pipe. When we graphed our exponential growth, we had a curve that went up this way, and now we have a curve that goes the other way. So I like to think about it as the other half of the other part of my half pipe. So 2 very important points again that we got to notice is our y-intercept. There it is. And our when x is equal to 1. So when x is equal to 1, there it is. And our y-intercept, there it is. Again, the 2 most important points that I care about, 2, are my y-intercept, 0a, and when x is equal to 1, 1 comma a times b. If we notice on this function, we do not have a k value or a vertical shift. which means our asymptote remains in the x-axis. So it is actually the x-axis. Again, this line is going to come down very, very, very close to the x-axis, but never fully touch. With that said, let's go ahead and revisit those 4 steps. Step number 1 was to list all values, or list all the values of variables given. What variables are we talking about? Well, that's a, b, h, and k. Step 2 is to plot my very 2 important points, 0, comma a, and 1, comma a times b. Step 3 is to apply any shift if needed. So if we have an h and a k, then we apply those shifts to our graph. Otherwise, we leave it alone. And step 4, draw the curve and find the asymptote. Remember where our asymptote is. If our k is equal to 0, or we don't have k, then our asymptote is going to be the line y is equal to 0, also known as our x-axis. Let's go ahead and graph let's work with the first example, and let's graph y is equal to 1/2 to the x power. When all else fails, guys, we can always create a table. So just like before, I can actually create an x and y table. Here's my x, here's my y. I'm going to pick a few points, and we can actually graph it. 0, 1, 2, and -1, -2. If we begin with 0, anything to the 0 power is 1. To the first power, we get 1/2. To the second power, we get 1/4. If we flip this bad boy around, we get 2, and then we get 4. Let's go ahead and graph these points. So 0, 1 is about there. Assuming the points don't go away. All right. We have 1 and 1/2. That's about halfway. And then we have 2 and 1/4. 2 and 1/4 is about there. If we go on the negative side, we get -1, comma 2. That's up here. And then -2, 4. That is up here. If we go ahead and connect our dots, again, we got to mind the asymptote. So we got to mind the asymptote. We're going to go ahead and draw our curve as best as we can without touching. That looks good to me. There we go. So this actually gives us our graph. Now, I taught you guys a shorter version, or my shortcut way, by following those 4 steps. Now, if we pay attention to our first steps, we notice that our a value is going to be 1. Our b value is 1/2. My y-intercept is 0, comma 1. And when x is equal to 1, I multiply these together, I get 1/2. Now, those points exist on my graph as well. Here's 0 and here's 1, so that's one of the points. And here's 1 and 1/2. That's the other point. If we just have those 2 points, then it's all right to go ahead and draw your curve, as long as you remember where your asymptote is at. In this case, our asymptote is at 0, or our x-axis. Now let's take a look at example number 2. In example number 2, I'm going to go ahead and go step by step. Step 1 is to find what a and b, h and k is equal to. In this case, we don't have an h and k, but we know what a and b are equal to. A is equal to 2, b is equal to 1/4. Step 2, my 2 very important points, again, my y-intercept, it's 0 and a, which is just 0, 2. And when x is equal to 1, I just multiply both a and b. This would give me 1/2. If you guys can't see that, we can always write it out. 2 over 1 times 1 over 4. We know that 2 divides into both of these evenly. This is a 1 and this is a 2. When we multiply across, we just get 1/2. And that's where this comes from. So let's go ahead and plot those 2 points. Here we have 0 and 2. And then we have 1 and 1/2. So it's about there. Again, since we don't have a k value, our asymptote is at y is equal to 0. Or in this case, it's just going to be our x-axis. So we're going to get very, very close, but we're not going to touch. So let's go ahead and draw our curve the best that we can. There we go. I think I can do better. Let me give it another try. There we go. Well, close enough. Yeah. There we go. As long as you guys know that it's going down this way and you can intercept those 2 points, this one's a little off. As long as you guys can show me those and label those 2 points, then we'll be all right. So this first point, my y-intercept will be 0, 2. And when x is equal to 1, I get 1/2. So we'll be all right. Now we have 3 examples depending on your comfort level of this lesson so far. We'll work these examples out in class. So we're going to be graphing a function given a h value and a k value, or in this case a horizontal shift and a vertical shift. So now we're going to run through all 4 steps using all 4 variables. So step 1 is to figure out what our a value is, b value is, h value is, and k value is. We're going to be using this function down here. So in this function, my a value is going to be 3. My b value is just 1/2. My h value is going to be -1. Remember, we always take the opposite of what's being added up here. Or in this case, we have x minus h. So we take the opposite value for h. And for our k, and if you guys remember, we do that because of the zero product property rule. K is just going to be -2. Step 2, we're going to plot our 2 very important points. Again, 0a is our y-intercept. A is just equal to 3. And when x is equal to 1, we multiply a and b to obtain 3/2. Oh, well. That's good. There we go, 3/2. Now, we do notice that we have a horizontal shift and a vertical shift. So our horizontal shift is actually 1 unit to the left. Since it's negative, we go on the number line, it's going to the left. And we have 2 units, or shift 2 units down. We're going down. So let's go ahead and plot these points and then do our shifts on those points. So this is very similar to the do now from our exponential growth function. So let's go ahead and plot 0, 3. Here's 0 and 3. So that's my first point. My second point is 1 and 3/2, which is just 1 and 1/2. So 1 and 1/2 is about there. So I'm going to take those points and I'm actually going to shift them now. I'm going to apply my shift. If I go to the left 1 unit, and then I'm going to go down 2 units. So this becomes my new point. Let's go ahead and mark that in black. All right. I'm going to do the same thing with the next point. I'm going to shift it 1 unit to the left. Here's 1 unit to the left. And 2 units down. So here's 1, and then here's 2. So if we mark it in black, it should be about there. Cool. Now we got to go to step 3. Shift does happen. So we also have to shift the horizontal asymptote. Now we're used to seeing the horizontal asymptote as our x-axis. So something we notice is that if I were to shift my x-axis 1 unit to the left, it still remains aligned. It's still aligned. It doesn't matter how many we shifted 40 units to the left or 40 units to the right, it still remains aligned. So now we're going to shift it 2 units down. So if I shift my entire x-axis 2 units down, meaning my horizontal asymptote 2 units down, I'm going to end up at -2. So my horizontal asymptote is actually at -2. So if we draw it, it's at -2. Meaning when my curve, or when I draw my curve, I'm going to get very, very close to this asymptote, but I'm never going to touch. I'm actually going to go through my x-axis and hover just above my new asymptote. So I'm going to go ahead and draw that out. I'm going to start up here and get my curve. See how good I am at this. There we go. And curve very, very close to it and not touch it. There we go. And that's what our graph would look like. So let's go ahead and jump into, so that concludes the whole graphing portion of this lesson. So let's go ahead now and talk about our exponential decay models. So we had an exponential growth model and we had a compound interest model, which is also a growth model. This is the decay model. If one is growing, decaying is shrinking, or it's getting smaller and smaller as time goes by. Speaking of time, let's go ahead and label a few of these points. T is, for time. R is going to continue to be our rate. And remember, we take rate in decimals. And A is going to be our initial amount. So there's nothing different about the variables. The biggest difference between a growth model and a decay model is this right here. In our growth model, that was a plus. In our growth model, we had addition because we were adding a certain rate to it. As time went on, we were adding rate. Well, in decay, in our decay model, as time goes on, we're subtracting by a rate. So let's go ahead and look at an example of this. We have example 5, snowmobiles. A new snowmobile costs $4,200. The value of the snowmobile decreases by 10% each year. Write an exponential decay model giving the snowmobile's value y in dollars after 2 years. Estimate the value after 3 years. So let's begin this problem by writing that exponential decay model. So if we look back at our previous decay model, we had that y is equal to a, 1 minus our rate, and time. Well, there's some very important keys, there's some very important information that we have to highlight here. That being, our amount is 4,200. That's our initial amount, and we're decreasing by 10%. We're decreasing by 10%. So our initial amount, or A, in this case is going to be 4,200. Our rate, remember in decimal, is 0.1. So we're going to go ahead and substitute all of that information into our decay model. We get 4,200, 1 minus 0.1 to the t power. T is time. If we simplify that expression, we're left with 0.9 to the t power. So this actually becomes our decay model. This is our equation to model all of this information given to us. So now we want to find out the value of our snowmobile after 3 years. All we simply have to do is plug it in. So we get y is equal to 4,200 times our rate, or our decay factor, to the third power, 3 years. I don't know where that went away. Okay. So if we approximate that, we can punch that into our calculators. We end up getting about approximately 3,000. Let me see in my notes. $3,061 with 80 cents. There we go. Approximately. So we can determine then, if it is a decay model, if our initial amount was 4,200, after 3 years, our snowmobile is going to lose value. So it's kind of going to go down up to $3,000.61. Our second part of this says to graph the model. So we can graph it and use the graph to estimate the value of the snowmobile. Use the graph to estimate when the value of the snowmobile will be 2,500. So if I were to graph it, oh, look at that, there's a graph. We want to estimate when our snowmobile, so time, when t, our snowmobile, what year, or how many years, when we obtain 2,500, I think. Yeah, 2,500. So let's kind of analyze, let's look at this graph. 2,500 is up here, So it kind of hits around there. Now we follow that line straight down. Now let's see how well I can draw a straight line. That is not good. I'm trying to draw a straight line, but let's see if I can get that. It looks to be close to, yeah, there it is. It's actually hitting 5, which means if we were to answer our previous question, use the graph to estimate when the value of the snowmobile will be 2,500. Well, the snowmobile will be 2,500 in 5 years. In 5 years. So again, if we're doing a word problem, you're answering in words. So in 5 years, the snowmobile will be worth 2,500. Oh, missed the 5. 2,500. There you go. Got it. And that's how we would use exponential decay models. So the next slide is just an exit slip. So if you're in my class, you know we usually take about the last few minutes of class. That's it, guys. Short and sweet, to the point. I hope this video was helpful, and I hope you guys picked up a few new things by watching it a second time. All right, guys. See you later.